Find the antiderivative of integral x square root of x minus 3 dx. And we're going to find this using substitution. Now this example looks a little bit differently from other examples we've seen. And what I mean by that is the two functions aren't derivatives of each other right now. So our function underneath the root, square root of x minus 3, well, the derivative of that is 1, not x. So we run into the problem of, well, what do we do with this x? So let's start a u substitution and see what we can do with that extra x. So u equals x minus 3, what's under the root, and then du, the derivative of x is just 1, derivative of negative 3 is 0, so this would just be 1 dx, or just dx. And then we'll start the substitution. So integral of x square root of u du, because we can just replace the dx with du since they're equal. But now we have this extra x here that we need to do something with. So if we look at our substitution equation, u equals x minus 3, right now that's written in terms of u. What if we change it to write it in terms of x? So that means solve for x in the equation. So to solve for x, we'd add 3 to both sides, and u plus 3 would be equal to x. So instead of x now under the integral, we're going to write u plus 3. And it may not be immediately clear that this is better, that this is easier. It looks like we pretty much have something that looks the same as what we started with. But if we change the way that things are written a little bit, then we're going to be able to do something here. So let's change the square root to u to the 1/2 power. If we do that, then we can distribute this single term into the parentheses here. That would give us integral of u to the 1 plus 1/2, so 3/2, plus 3u to the 1/2 du. And now we do have something that we can integrate. And we can do this integration term by term. So u to the 3/2, add 1 to the power, that would be 5/2, and then divide by the new power of 5/2, plus 3 u to the 3/2 when we add 1 to the power, and then divide by the new power of 3/2. We want to rewrite this so that we don't have fractions within fractions. So this would be 2u to the 5/2 over 5. When we flip the fraction, take the reciprocal of the fraction in the denominator, plus 3 times 2u to the 3/2 over 3 plus c. And then we see that these 3's here are going to cancel out in this second fraction. And then we can resubstitute x minus 3 for u. So 2 x minus 3 to the 5/2 over 5 plus 2 times x minus 3 to the 3/2, and then plus the constant c. So this answer is correct and sufficient A different way that you could possibly write it is to bring back in the square roots. I'll show that way as well. That would be 2 square roots of x minus 3 to the 5th over 5 plus 2 square roots of x minus 3 to the 3rd plus the constant c. So either one of these methods of writing the answer is correct.